We're facing this massive energy challenge, and it's forcing us to have some pretty tough conversations about our future. So today, we're going to tackle one of the most controversial questions out there. Can nuclear energy really, actually save the planet? And this quote right here, it just perfectly sets the stage, doesn't it? The stakes are incredibly high. We need clean energy, and we need a lot of it, like yesterday. So the big question is, where does nuclear fit into all of this? So take a look at this. It shows a pretty stark reality. Now, renewables are growing at a record pace, and that is fantastic news, truly. But fossil fuels still completely dominate our grid. We're talking about 60% of all global electricity. And nuclear, it's just sitting there at around 9%, a number that really hasn't budged in a decade. And all of this is happening while our thirst for electricity is just exploding. I mean, think about it. Electric vehicles, industry, and now the absolutely massive energy appetite of AI data centers. This has thrown nuclear power right back into the center of the conversation. So let's get real. Can this 9% player actually become a climate game changer? It's time to unpack the evidence. Okay, first things first. Let's look at the hard numbers. If we're going to understand nuclear's role, we have to cut through all the noise and really examine the two things that matter most in this whole debate: its impact on the climate and its safety record. And wow, this chart right here pretty much makes the climate case for nuclear crystal clear. When you account for everything, and I mean mining, construction, running the plant, taking it down, nuclear's carbon footprint is tiny. We're talking around 12 grams of CO2 per kilowatt hour. That puts it right down there with wind power, and it's even cleaner than most solar. I mean, compared to coal, it's not even a contest. So if cutting emissions is your main goal, nuclear is absolutely in the same club as renewables. Of course, the second you say the word nuclear, this is what everyone thinks of, right? These names. They bring up this deep, almost primal fear. And look, it's a fear that has shaped public opinion and energy policy for decades. But how does that fear stack up against the cold, hard data? This chart is pretty staggering. It compares deaths per unit of energy, and that includes both accidents and the long-term deadly effects of air pollution. And the results are just mind-blowing. Coal and oil are responsible for thousands of times more deaths than nuclear. Even when you factor in the absolute worst nuclear disasters in history, it is still, statistically, one of the safest forms of energy we have, period. So what we've really got here is this fundamental mismatch in how we perceive risk. On one hand, we are absolutely terrified of these rare, catastrophic nuclear accidents. But on the other hand, we've kind of just accepted the routine, widespread, and deadly pollution from fossil fuels that happens every single day. And understanding the psychological gap, well, it's key to the entire nuclear debate. Okay, so if nuclear is so clean and statistically so safe, then why isn't it everywhere? Well, that brings us to the two giant, very practical hurdles that have always plagued the industry: money and waste. Let's talk about the cost, because it's a big one. Building a new nuclear plant is incredibly expensive. It requires this massive upfront investment and takes a really long time to build. The estimated cost for a megawatt hour from new nuclear? Somewhere between $90 and $120. That is way higher than a new solar or wind farm. And for any investor, that's a huge, huge risk. But here's the catch, and it is a big one. This chart shows what's called the capacity factor, which is just a fancy way of saying how often a power plant is actually running at full steam. And nuclear plants, they're total workhorses. They run over 90% of the time, giving us constant, reliable, always-on power. Solar and wind, well, the sun isn't always shining and the wind isn't always blowing. So yeah, nuclear is expensive, but what you're paying for is that incredible reliability, which is absolutely critical for a stable grid. And now for the other big challenge. What do we do with the radioactive waste? Well, here's the surprising truth. The actual volume of high-level waste is physically very, very small. And the science for how to store it safely, deep underground in geological repositories, that's been well established for a long time. The real bottleneck here, it isn't physics, it's politics. It's public opposition and a total lack of political will that have stalled permanent storage solutions for decades. So, given these huge challenges of cost and politics, the nuclear industry is basically betting its future on a new idea: thinking small. Let's dive into small modular reactors, or SMRs, and see if they can finally solve nuclear's oldest problems. So the core idea behind SMRs is actually pretty simple. Instead of building these massive, one-of-a-kind mega projects on site, what if you could just mass produce smaller reactor parts in a factory? The big hope here is that this kind of assembly line approach will slash costs, speed up construction, and make the whole system inherently safer to operate. And this isn't just some theory on a whiteboard. There's a global race happening right now. China is already building the world's first commercial SMR. Canada is breaking ground on 4 new units in Ontario. And countries like Sweden are making SMRs a central part of their future energy plans. The momentum is definitely real. But it hasn't all been smooth sailing, not by a long shot. This timeline for NuScale, a leading US developer, perfectly shows that whole hype versus reality challenge. Their big flagship project? It was canceled in 2023 because costs were just soaring. But then, just over a year later, their updated design gets regulatory approval, and now they're in serious talks to power those super energy-hungry AI data centers. It's a real story of both major setbacks and really promising new opportunities. Okay, so we've looked at the climate case, the safety data, the economic hurdles, and the future tech. Let's try to bring it all together and answer that central question we started with. What is nuclear's realistic role in all this? I think this quote really nails the conclusion here. Nuclear is not a silver bullet. It is not going to single-handedly solve climate change. But trying to build a stable, zero-carbon global energy system without it, that job becomes incredibly difficult. It's a crucial tool, and we have to have it in the toolbox. So the smartest path forward probably looks something like this. Step 1, you go all in on renewables and efficiency. That's the fastest and cheapest way to cut emissions today. Step 2, you use nuclear, both existing and new plants, as that reliable 24/7 backbone that keeps the lights on when the sun isn't shining. Step 3, you invest in SMRs as a potential long-term game changer. And step 4, you use all of this to get fossil fuels, especially coal, off the grid as fast as humanly possible. And that really brings us to the final thought. Maybe, just maybe, we've been asking the wrong question all along. This isn't about being on team nuclear or team renewables. The real question is one of pragmatism. Faced with a challenge this immense, with a clock that is ticking so loudly, are we smart enough and brave enough to use every single effective, low-carbon tool we have to get the job done?